Okay, in this problem we're going to be looking at flow between two parallel plates that's driven by a pressure gradient with the pressure high on the left hand side and low on the right hand side. So the key to this problem is to make sure that you uh, model only the places where the flow is going to be and not model the plates themselves. So this is going to be a 2D problem. So click on 2D, click Next, then I click on Fluid Flow, Single Phase Flow, Laminar Flow, and then click on Next. So you can see that's added to uh, the selected physics. This is going to be a stationary problem, and then I click on Finish, and then over here in the model builder, the model being set up for us. So we're going to define our area to solve as a rectangle. So I can go into here and choose rectangle. Alternatively, I can go up to my menu here and draw a rectangle. So let me do that. Um, this is snapping to grid right now, and it's not drawing it exactly the way I'd like it, so I'm going to go and find this rectangle and change some of the dimensions. So it's going to be 50 e to the minus 2, and the height is going to be 1 e to the minus 2. So that's 50 centimeters long, 1 centimeter high. The corner is at 0, 0. If it wasn't, then I could change that too. Okay, so let's build selected, and you can see we have a long and thin area, which is going to have flow. So the material we're going to use is going to be water, so I can right click on that and open up Material Browser and go to Liquids and Gases, click on Liquids and click on Water, and then add that model to the material, so the water is right there. Then go down to Laminar Flow. The default value here is compressible, so I want this to be incompressible flow. And I could neglect the inertial term because this is a long and thin, but for right now we'll just solve the full Navier-Stokes equation. Okay, so under laminar flow though, I need to add my wall conditions. So I can click on this first one and notice that I have walls 1, 2, 3, and 4, where 2 and 3 are no slip boundary conditions. So if I click on 2, see that it's a no slip. Unfortunately, 1 and 4 are also listed as no slip, and we don't want that. So what I can do is go up to laminar flow, right click, and add an inlet. Okay, my inlet is going to be over here. It's a little bit hard to see, so I'm going to go up here and select the zoom box, and then select that so I can more easily see, work there. You can select boundary number 1, add that to the model, and make that an inlet pressure, and we're going to make that 1 Pascal. I need to do the same for the other side. Unfortunately, I can't see the right hand side, so I can click on this button called Zoom Extents. That just brings the entire model into view. I can click again on this zoom box, go in here. Before I do that, I want to go here and make sure I add my outlet. Okay, so now I have my outlet. I'm going to click on number 4, add that to the model, and that's going to be a pressure, and that's going to be a value of 0. So now ready to go down to the mesh. So this is listed as a physics controlled mesh. I happen to know that gives a pretty dense mesh, and it takes a little bit longer to solve. It would be perfectly fine. I could also just change the coarseness of it. And let me just try that. It's going to be fine, I think, though. So element size we're going to have as coarse. It's not going to be quite as good as normal, but it will solve a little bit faster. So we can go to study, and we see that it's stationary, so we can go ahead and click the equal sign and compute this. So we'll get a sense now of how long it takes to solve that problem with the mesh as it is. Okay, looks like it's just about done. Okay, and so you can see that we have our velocity profile. This is velocity magnitude in meters per second. It has a peak value of 0.023 and a minimum value of 0. Can't see the whole thing right now, so again I can do zoom extents. You can also look at this boundary in the beginning. And what we can see is we have some entrance effects here with boundary layer formation and so on. Okay. So that seems to solve fairly well. One of the things I've asked for is to plot the velocity profile at the midpoint here. And in order to plot a velocity profile, we need to have a line over which that velocity profile can be plotted. So in order to do that, we need to go back to our geometry. I can right-click on that, and I can add that line as a polygon. And the coordinates are going to be, let's back in, the coordinates are going to be x is equal to 0.25, that's halfway, and we're going to have the same x on the top part, so I'm going to space 0.25, and then for y it's going to start at 0, and then it's going to go up to the top, which is 0.01. Okay, so that's a line with two coordinates. I can build that, and we can see that it adds that right in the beginning. Okay, I can then go to my results, and I can choose a 1D plot. Okay, so there's my 1D plot group. In order to choose that, I have to say which kind of graph I want. So I'm going to choose a line graph, and what I can do is check out to see if my line is there. And you can see that the line is not there. It's because I didn't solve this with the line there. So I have to go back to my study and click equals and solve this problem again. So we're going to have to wait for that. Okay, so you can see we've solved it and the line is there. So now I can go to this line graph. Okay. And I can see that my line appears here. I can go and select that line and add that. Okay. If I'm just looking for velocity, I can see that I have my velocity view, which is the x velocity. In another tutorial, I'll show you how to change that. The x data is going to be arc length, and this just means that it's plotted along whatever the arc is, whatever distance is. So we could have another types of parameters to plot. Okay, so I can go ahead and select this to plot, and you can see we have our nice velocity profile with our maximum there. Okay. Okay, so the last thing I'd like to show you is after we've gotten this plot group, so this was formed by taking a 1D plot group and making a line graph along this line number 4. What I'd like to show you is how to export this data to a file. So this is going to be data on the velocity profile along number 4. So I'm going to right click on report, and I'm going to essentially look for a plot. And this plot, the plot group, is not going to be the 2D plot group, which has that surface. It's going to be the 1D plot group, and the 1D plot group has a line graph underneath it. That is my only choice there. So what I'm going to do is save this as a spreadsheet or text file. I'm going to call this test4. I have a few other ones that I've worked on. I'm going to save this, and then I can click on here to export it. Some of the other formats are shown here, but spreadsheet is what we want. Okay, so I've exported that. I'm now going to, so that's on my desktop. I'm now going to go to Excel, open this up. That's what I've done already. So I have a blank sheet here. In Excel, I can go to Data, and then insert data from text. Click on test4 and import that data, and then I end up with this text import wizard. And this is going to be delimited text. In other words, it's going to be delimited by spaces. So this, and you can see here that my data is right here, but it has a space in between. So I'm going to do that by spaces, and that makes that go into columns. And click on Finish, and click on OK, and then I have my data, and I can select this data, then insert some kind of plot, and I can show you that I have this. So that's an explanation of how to get the velocity profile from COMSOL Multiphysics and to export this as data into a file. Thank you.